I'm Mike Ungerman of the Central Florida Computer Society. I installed the solar photovoltaic system you see in this photo on my residence in Florida in two phases between 2017 and 2019. In parts 1 through 4 of this series, we covered the technology of producing solar photovoltaic energy from a system for individual homeowners to place on the roof or on a rack located on their property. We also looked at some resources to enable us to determine if solar electric production would be efficient, potentially affordable for our residences. Now let's take a look at how I went solar starting back in 2017. In a previous presentation, I reviewed how analyzing your utility bills can start you on your path to a decision on whether to invest in a solar PV system. Here again is one of my utility bills from 2017. Note that it's above $400 a month and that I have considerable energy usage above 1,000 kilowatt hours per month. This is the highest tier, and it's a target I wanted to reduce. At the same time, my long-term investments were not producing significant current income. Switching to aggressive income-based investments were producing very little interest or dividends without also increasing the risk of capital. Running the numbers for an investment in a solar PV system indicated to me that I could profit from this course of action through short-term savings of from $100 to $300 per month on my utility bill, an initial offset of investment capital by federal tax credits, and long-term recoupment of investment with positive cash flow after 7 to 10 years. As a technically oriented person for most of my life, the concept of producing my own electricity and selling excess back to the utility system intrigued me. Having watched the technology of solar PV develop over the years from a concept to prototypes to affordable production convinced me that it was time to make the jump. I had considered solar early on to reduce my electric bill. My first focus was installing a solar hot water collector on my roof and an 80-gallon hot water tank in my garage. At that time, it reduced my already high utility bill by about $40 a month. In early 2017, I answered a knock on my door by a solar company soliciting our neighborhood. Against my better judgment, I let them in and we discussed going solar. The end result was their proposal to install a full array of solar panels with a static standalone inverter for approximately $65,000. So, following a thank you very much, but no thanks, I was sparked to do my own investigation using resources much as I've mentioned in my previous presentations. I did online research of local solar companies, eventually making appointments with 2 of them for estimates. I also attended at the formation meeting of the local county solar co-op under the auspices of the Solar United Neighbors nonprofit organization I also previously mentioned. Here's their link. Subsequently, I did join the co-op and was asked to participate in the selection process from competitive bids that they received. In the next 2 slides, I'll review the competitive bidding process with the factors that we considered for our selections. Each of the bidders were required to respond to the items listed here and were allowed to provide any additional supporting information they wanted. For those of you seriously considering a solar PV system now, I'd suggest reviewing this video of the presentation at a later date, pausing the presentation and noting the factors for your own analysis processes. In this list, the focus is on the providers and their qualifications. Selecting a reliable and responsive provider is a major part of obtaining, installing, and supporting your solar PV system. The last thing you want to do is pick a provider primarily on price and then find that they are out of business and you have no source of support. Following the co-op selection process, a provider was selected. Participants. I contacted that provider and requested an on-site inspection and proposal. They visited us, inspected the house, including an analysis using their software of the available locations for solar PV panels. The initial quote they gave us was to provide a complete offset of our high usage monthly utility bills, and it was approximately $45,000. Once again, too high for me to accept without taking out a loan, which I really didn't want to do. So we do what we mostly do when we go buy expensive stuff. I gave him a counter offer. I said, "What can you provide me for $15,000? All in." That did not include the federal tax credit, which the previous company's estimators wanted to include. Knowing that what I would receive would not offset my entire utility bill, I received an acceptable quote. So here's what I purchased. 25 REC Twin Peaks 2 Series 290 watt solar panels, subsequently modified to 26 panels of 285 watts each when the 290s were not available at the time of installation. The total actually wound up being more in terms of kilowatt production, 7,410, than I would have gotten with the first quote. Then we got 11 AP Systems YC500 dual channel microinverters. Again, subsequently increased to 12 when we increased the number of solar panels by 1 because of the higher output not being available. Then one AP Systems Energy Communications Unit, or ECU. It's a communications controller via power line protocols to the installed microinverters, and receives power production statistics and makes them available to their energy monitoring application, which is available on the web and mobile devices. The rack mounting system should be more than just a series of attachments to your roof. In my case, I was offered an upgrade to the Snap and Rack roof mounting system, which I accepted. As you can see from these pictures, it integrates the mount itself with a system for mounting microinverters or optimizers with the wiring connections. It also eases the connection of the panel to the rack, allowing access for installation, maintenance, and potential removal and replacement as required. In addition to the major components just shown, the quote I received included all installation materials to include a solar service panel on the exterior wall of my home that I specified had to support up to 2 times the number of panels of this present installation for future expansion. The quote included all installation labor, engineering design for the installation, to include professional engineering drawings, which were submitted along with the necessary required county permits. And my warranties included a 10-year roof penetration and workmanship warranty, a 20-year snap and rack mounting warranty, 25 years REC solar panel warranty, 25 years AP System microinverter warranty, and 3-year warranty with AP Systems ECUs. So I got very close to the $15,000 price I had set for myself, and the co-op's negotiated discounts played a significant factor in what I was able to get for that amount. I chose not to finance this installation, considering my previous analysis of what I might expect to save on monthly fixed costs and what I wasn't earning on my savings. I invested a portion of my savings to purchase this installation. I documented the solar PV installation at my home, which consisted of 2 parts: a physical installation of the major equipment and wiring from the roof to the side of my home, then an electrical installation which followed the physical by several days. Let's take a look at my Google Photos album documenting this installation, and you can revisit these with the links shown here. So you can see the contractor that we went with. Their team showed up, and here's some of the initial preparations they're making. You can note the roof space that they're going to put on the right and on the left side. I have a skylight that they had to consider. I've got some fans they had to consider, some vents they had to consider, and the solar hot water collector. You can see them working up there, basically starting to find the studs in the rafters and the joists, and then to drill in their pilot holes. And now they're starting their drilling. Here you can see the first group of the installation studs, along with part of the snap and rack mounting system bases. Once the bases are in, you can see that they've got these base plates, and on these plates they put a whole bunch of mastic, and then they flip them over and slide them under the shingles. And here they are installed. Now the snap and rack assembly itself attaches to the mounts. They're also drilling a hole for a junction box, which is going to pass the wiring through into the Atlantic once they collect everything, all the wires from the microinverters. Here's the snap and rack system now installed, and some of the microinverters are already going in. Meanwhile, down on the ground, the wires are being laid out and prepared. Photovoltaic power source wiring has to be fed from the junction boxes on the roof down to the side of the house. You can see just how long some of these cables have to be. And some of the cables now have already been installed. Here's the junction box that I mentioned, with the cables feeding to it and going into the attic. Now the panels are prepared. Backside of the panels actually only have 2 connections. Because it's a snap and rack, the panels themselves don't have to be screwed to the rack. They snap in and lock in place with just 2 or 3 mounting bolts that secure them and provide the necessary wind resistance. First assembly is just about complete. Second assembly is going in. And second assembly is just about complete. When they finish, all the wires have been fished to a single point through the house, and the tubing comes out on the side of the house. Here's what the physical assembly looks like. Looking at it, you can see the 9 units that are up here and the remainder of the units that are over here on this side. This is a south-facing roof, and this is an east-facing roof. Once that is done, several days later, actually a week later, an electrical installation has to be done by an electrical team. So again, here is the wires coming off the roof, and here is what my entrance panel looked like before they started. Now we start installing various components. This is the main entrance panel. They're putting a shut off so that you can shut everything off, getting that wired in, putting in the necessary extension boxes, putting in its own dedicated grounding rod, part of the shut-off assembly. Now we get a panel of circuit breakers for each one of the banks of microinverters. The AP Systems ECU, master on-off switch, which is also fused. Here's the box that the ECU is going to go in. An overview of all the new components. And now the wiring is complete and just waiting for the power meter to be replaced by the utility company. ECU is on and showing that it's connected to the panels and that electricity is being produced. The payoff for my solar PV system was in the reduction of my utility bill, as seen here. Basically $200 a month, although I had a number of energy credits applied as a result of getting solar. Fast forward to 2019, another solar co-op was being formed in our county. I was contacted and asked if I would like to be on the selection committee again, and I agreed. The process in the previous slides was essentially duplicated. Along the way, I decided I wanted to get my utility bill to $100 or less if I could, and still stay below my $15,000 target to do so. The result was that I contacted the winning bidder and negotiated additional panels, now physically larger and more efficient solar cells. Their quote was well below my target price. For the same reasons already discussed, we went ahead and installed 13 additional panels and a second ECU, which was required because there were different communications protocols now with the new panels. Here's a picture of the combined systems once the second phase was installed in 2019. You can see the differences in the panel design. The newer ones contain more cells and are longer. The full array is on the back of our home facing away from the street, so I wasn't that concerned about having all the panels look alike. And the payoff for the combined system was the reduction of my utility bill as seen here. Now, more than $300 a month from before solar PV. There was a dip in May. We had taken a couple-week vacation and shut just about everything but the air conditioning off while we were gone. I did want to include a quick note on the latest changes to the U.S. federal income tax credit for solar PV. Homeowners will now be able to take a 30% tax credit off the cost of their installation for systems installed between this year and the end of 2032. The credit then steps down to 26% in 2033 and 22% in 2034. The bill includes tax credits for home battery storage energy systems at the same percentage for solar systems, something I haven't yet considered. Overall, I have no regrets about going solar PV. If you can afford it, I believe it's a great investment. And if you can qualify for financing, consider the recovery of your expenditures in the light of the continuing federal tax incentives, and then the future payoff. And so, next up, electric power vehicles. One of the uses of my solar PV system is the free charging of my Kia Niro plug-in. And here you can see the cable that I have attached to it. Stay tuned.
It's Ron Brown with Tech for Senior. It's October the 8th on Vancouver Island in Comox, British Columbia. It is a gorgeous day and beautiful October. I decided to go out and mow the grass to show my friends how wonderful it is. It's very unusual that I'll be mowing the grass in October, so I wanted to go out and do a short clip and show everyone how warm it is in October. So here we are, and as you can see from the video, there's a big error that I made. How do you fix this? Let me show you. Now obviously we have to turn the image to make it look correct. As you can see, most basic photo editors, it's very easy. You can turn it to the left, you can turn it upside down, you can turn it right around. But remember, this isn't an image, this is a video. It's not so easy to turn a video because a video is made up of thousands of images. But one of the unique features of Google Photos, not found in very many other products, is that you can indeed easily turn a video. This is a very cool trick. Let me show you how it's done. The ability to turn a video in Google Photos can only be done with the Google Photos app. So this means that you can do it, of course, on an Android phone. You can do it on an iPhone. You can do it on an iPad and a Chromebook. But you cannot do it on a PC. Today I'll be showing you how to do it on my Pixel 6 phone and my iPad. Let's have a look. This is my Pixel 6 phone. Let's open Google Photos. Here we go. And here is the video we're going to play. Now, as you know, it needs to be turned. So what we're going to do is we're going to pause the video. I'm just going to click the pause button here. Now I'm going to come down to Edit, and we're going to move over to Crop. Let's move over to the Crop button. And just above my finger, you'll see another little button here. We're going to click this, and it's going to turn the video for us. Now watch as we save a copy, and then I'm going to replay it, and you'll see that the aspect is now correct. That is so simple and easy to do on the Google Photos app. Let's have a look at my iPad now. We're going to open the video, and again here you'll see we want to turn this. So I'm going to come up and we're going to tap the video, and we're going to stop this, and then I'm going to edit it. So we click the edit button, and again you'll see it opens up a sub menu, and we can click the crop. Now next to the crop, we're going to come up to turn, and there we've just turned the video. And I'm just going to move the iPad down a bit. We're going to save it. I'm going to click the save button. We will now see the video right way up. Isn't that pretty cool? That's on my iPad. Now I'm going to show you as well how to trim your video, because at the beginning here we don't want this part of the video. So I'm going to delete that. So let's open the video. We're going to click Edit. This is done on my iPad, but it is the same for Android and iPad. I'll only be demonstrating it on my iPad today. So as we come up now, we're going to come back to video. We don't go to the crop menu. We're going to come back to the video, and we're just going to take a slider bar and we're going to slide it along, and that will eliminate the first part of the video. So we're going to come down, and I want to just get a picture of me mowing the grass, not setting up. So we'll just slide that down, save, and now it starts from that point. So in this video, we've learned how to rotate our video in the Google Photos app. We've also learned how to trim our video. It's Ron Brown with Tech for Senior. Remember that like and subscribe. Until we see you again, have a great day.
Traffic cameras, I'm Hewie Poplock. Recently, one of our local TV stations had some information about a traffic accident on their website and showed some live cameras of the traffic jams that it was creating. And so I went to where they were showing this, and it's a website called smarttrafficinfo.org. What it's showing here are a lot of cameras at various intersections in Sarasota and Manatee County. Let's take a look at what they show us. Let's take a look at one of the intersections. It's Cortez Road at US 41, which is 14th Street West. You'll see down here a live shot of what's going on. Let's make it full screen so you can see it better. I don't know if you noticed, but it just switched cameras. There's actually 4 or 5 cameras at this intersection, and every few seconds it will switch cameras to show you the traffic at that particular moment. These are live, and it's going to switch cameras, and it's showing a different direction. It's after 6 in the afternoon, so the sun's starting to go down a little bit, but you can see that there's traffic flowing in all directions, and lots of traffic as well. If they had cameras like this in this area, what about in other areas? So I went searching, and I found out that the FDOT, or the Florida Department of Transportation, also has cameras throughout the state. And you can see here. So if we go and look at the Orlando area right here, we can zoom in and we'll see that there's a lot of cameras. So let's take a look at a camera. And there's a camera there. And we can show a video. And so most of the major highways in Florida have cameras located, and you can check out the traffic in a particular area. So I said, well, if Florida has that, what about other states? So I'm suggesting that you take the live traffic cameras and then whatever your state or province is and put it right after that and do a search. And let's see a few of the ones that I came up with. There's Colorado. And if you take a look at the Colorado one, you'll see down here, it says web cameras. When you click on that, you will see an area here where you can click on what you're looking for. So if I click on cameras, you will see that it populates with a lot of different cameras. Now, not all states work the same way as Florida does. Some of them only show you a snapshot of a particular moment. Some of them show several snapshots in a row. But let's take a look at what we've got here. So let's take, I don't know this area, so I'll just click on it, and there is a camera shot of I-25, and it's 0.2 miles south of Palm Creek Parkway. You'll notice that it's standing still. If I click on it, it becomes a live video. I can go to the next camera down the road, click on it, and I'm seeing a live video there. Okay, let's stop this. Let's go to the next one here, and this happens to be California. And you can see that there's a lot of cameras here. Let's just zoom in on any one. I don't know the area, but let's just click on it. Click on the start here. Click here. And you're watching it live there as well. It's telling it what the weather is, gives you more information, says where it is. And it is live right now. So we'll stop that. Then we'll go, I checked Delaware. Let's take a look at Delaware. You can see there's a whole bunch there. Let's click on one of the cameras there. It's live. And you can see sun setting, so it's getting a little dark. But it is Delaware. Let's close that. And I checked Texas. And again, there's a whole bunch here. And what they do is, I believe these are state law for fender benders. So let's see if we can find a camera here. These look like strictly a photograph. But again, you can play with it, see what you get. You might be able to get live access. Let's take a look at Ottawa. Now, this site, traffic cams, we're going to take a look at a few things in traffic cams, but you'll notice here that that was an ad. So you got to be careful what you click on. But as we zoom in, we can click on something here and click on that. And we want to close that because that was an ad. And there is the Old Ottawa Highway near Nicholas Street. And it looks like it is not a video, strictly a picture. What I want to show you here is down below this. We scroll down, we see several pictures and so on, but we'll see all of the states. You can pick whatever state that you're in and take a look at it using the website traffic-cams.gov. ℏ𝕠𝕟.com, but note that there are a lot of advertisements and be careful what you click. So when it says start, that's an ad. You can move it out of the way, but it'll come back. But you can go to any state. If you want to go to Michigan, you'll see all of the cameras in Michigan, and they're loading now. And these are certain cameras in Michigan. And you can find various locations. That is webcams for traffic. Try it for your area and see if you have cameras available. I'm Hewie Poplock.